Here's an example question. If the length and breadth of rectangle increase by 20% and 25% respectively, what is the percentage increase in the area of the rectangle? Let's first look at what's happening in the background, and afterwards let's look at the very little that you need to actually write to get the answer after understanding the concept. Okay, so we basically have a rectangle whose area is length into breadth. So you have a new length which is 20% more than the old length, so it's 1.2 L. A new breadth which is 1.25 B. So your new area A dash would be L dash into B dash, which is 1.25 L, 1.2 L into 1.25 B. So when you try to calculate what's happening to the ratio of A dash by A, it is 1.2 L into 1.25 B divided by L into B, which is basically 1.2 into 1.25, which turns out to be 1.5. This basically means that A dash is 150% of A, or in other words, it is 50% more than A. This is basically what's happening. We write the new area in terms of the new length and the new breadth, and we then write the new length in terms of the old length, and we can get the ratio. And once you have the ratio, it's basically final by initial minus 1. Final by initial is we get final by initial is 1.5. You take away the 1, you have 0.5, which is 50% more. So that's basically what's happening. But when you get a question like this, all you need to do is this: write the corresponding formula. Percentage, it is given length increases by 20%. I'm going to write it below. Length increases by 20%. Breadth increases by 25%. This is the information that's given to you. And area increases by what percent? Convert to percentage of. Length is 120% of the old length. Or you can write the fraction. That will also do. Whenever you have convenient fractions, you go with the fractions. The new length is 6 by 5 times the old length. The new breadth is 5 by 4 times the old breadth. Once you have converted percentage more to percentage of, you just multiply it and you get 6 by 4 or 3 by 2. And then you convert back to percentage more. 150% off is 50% more. That is the answer. Let's look at another very similar example. Here we have a volume instead of an area, and we're dealing with a cuboid. So you directly write the formula: volume is equal to length into breadth into height. It's given that the length increases by 20%, so it increases to 120% of its old value. So you can write 120%, you can write 120 by 100, you can write 1.2, but just write the simplest fraction of that value. 1.2 is equal to 6 by 5. The breadth increases by 40%, which means it becomes 140% of its older value. That is 7 by 5. What happens to the height is the unknown, so just put a variable there. What happens to the volume is given to us. It increased by 26%. That is 126 by 100. Now you just cut what you can cut. 5 and 5 will take out 25 from the 100. You will have 4 left. 6 by 126 is 21. 21 by 7 is 3. So you're directly getting h is equal to 3 by 4, which means that the new height is 75% of the old height, which basically means 25% less. The reduction percentage change in the height is a 25% reduction.